All right, everything looks to be a go. I got the nice little green screen, so hopefully everything is set up. So first off, it is crazy windy outside right now. So if you see me kind of randomly looking off in that direction, it's because there's a whole bunch of leaves and things like that swirling around. So I don't know, it's crazy. So I guess blame South Dakota weather for, somewhat distracting me as I look out the window. So anyway, in our last activity, I actually had you play around with some hashing as well as this introduction of salt to our hash. So typically this salt is going to be generated through some cryptographically secure pseudo-random number generator, which actually sets up the stage for our discussion of pseudo-random number generators very nicely. So down below, you can see I got my little dude here. He doesn't really have a sword or anything like that. He's just randomly going to be spitting out various numbers. So you can see this nice little seed value of 1337, and then it randomly generates into 7875, and so on. So this section goal is really to look at a few of the classic pseudo-random number generators and set the stage for some of the newer tools. So as is always the comment around crypto, you should really not try to create some of these on your own, but just ensure you're actually using the recommended protocols and procedures. So our goal is to give you a little bit of the kind of taste for what's living in the background of some of these objects so that when you later use them, you kind of have a little bit of appreciation of what all of that random circling and stuff like that is all about. Before we jump into it, there's a little bit of word soup and initialization, which I realized right before I hit record on this. I was like thumbing through to make sure nothing was super duper broken, and I had the initialization of the cryptographically secure pseudo-random number generators wrong, in that I had a letter S inside of it instead of the needed R. So the original pseudo-random number generators will be initialized as this PRNG. Sometimes they're going to be referred to as these deterministic random bit generators, so DRBG. And then if you actually have them serving some of these nice cryptographic purposes, so they're kind of properly vetted, then they get the extra two letters of the C and the S for the cryptographically secure. So like I mentioned before, we'll kind of start old school, kind of going back to the 1940s, which actually has our first one, which is generated by John von Neumann. And he has this nice little quote down below, which is basically saying that if you start with some deterministic and static things, you're doomed to fail, which is true amongst any of these random number generators, is that if you feed it in with a bunch of deterministic stuff, guess what? You're not going to get a very good, attempt at being random. So in this, I guess, world of some of them, of all of this stuff, I should say, not some of them, we do have, like I said, a lot of that word soup going on. So the first thing to note is that there's those two really big bins. There's going to just be kind of our classic pseudo-random number generators. So think about those ones as being very, very fast, but not being cryptographically secure. And those are the ones that go back, really far back, but they also still emerge and are still being recreated even to this day. So down below, we got kind of a cute little laundry list of them. There are hundreds of other ones that you could poke into. So in our notes today, we'll chat about the middle square one. We'll chat about some linear congruence, linear feedback shift registries, Rule 30, which is actually based off of some cellular automata you will see in our next couple of sections. So it has some cute visualizations. So there's the Mersenne twister, which is actually the way that Python is going to generate some of its pseudo-random number generators. So that's actually based off of these shift registry things. There's, things like XOR shift and square RNG, which is actually an improvement on the original middle square. And you can go on and on and on and on. There are a ton of them. There's many, many different implementations. I will spam you with a few of them on some activities and exams, just because it's nice to just, give you a little bit of background as to what this thing is doing, and then have you go and run it and explore a little bit of what's happening in the shadows. So those are kind of your initial kind of fast ones. On the other side, so the cryptographically secure ones, those are typically going to be much slower, as you would probably guess, because if they were comparable in terms of speed, then there'd be no need to even use the other ones. So these cryptographically secure ones are typically going to be, I don't know, 10 to 20 times slower than the other ones, but they obviously do have the added, secure advantage. And amongst them, there are actually a bunch of different ways that you can attack them as well. Some of the kind of nice early ones are actually going to be where we make use of some of our other cryptographically kind of secure or vetted processes. So some hashing functions, some stream ciphers, maybe some block ciphers, and basically let them kind of auto-generate things. So we'll play around in that a little bit. So once we've chatted about some of these hash functions, we can then, take a seed, feed it into a hash, take that, feed it into another hash, take that, feed it into another hash, and let that process go. You can also generate these things based off of some really hard math questions. So those ones are usually really, really slow in terms of implementation. So they're more interesting from, a theoretical point of view rather than an actual implementation. So those are the ones that you have down below. So there are some that are going to be based off of the difficulty of factorization. So we'll dig into this one a little bit. So it'll feel very similar to some of the setup of like RSA. So there'll be a couple primes, P and Q, that you're going to generate. You multiply them together to create your modulus N. And then you begin generating these things by constantly squaring and reducing mod N. That arithmetic is obviously very, very slow. And, it's obviously not going to be fully implemented just because of that speed aspect. The other one that we're not going to look at, but I might throw into some other activities, is going to be based off of the difficulty of the discrete log. So there's some order finding things that are going to exist in the shadows. Again, interesting from a theoretical point of view, not so great from an actual implementation side. So you have kind of that bin of things. And then you have the other bin that's going to make use of kind of all of this other crazy external entropy stuff. And for those of you that have played around on some of these pseudo random number generators, these are the ones that you've probably seen or probably played off of a little bit. Most systems have their own built-in processes that will have an amount of available entropy that you can actually play with, and then use that to then generate other things. So in the cryptographically secure landscape, there again are a ton of different things. They kind of bin themselves into ones that make use of other algorithms, ones that make use of some of these hard math questions, those that make use of kind of weird external factors, and then funneling them into various algorithms. So you can go on and on and on and kind of fully explore this world. It is a super deep rabbit hole because people are going to be constantly generating a new crazy way to randomly generate things. Sometimes they work, sometimes they don't. Sometimes they just get added to little lists like this and they don't get fully vetted. So it's something that you can spend an insane amount of time on, which I obviously recommend you doing, but it's also, something that we're, towards the end of the semester, so we have to shorten it up a little bit. So I will live a little bit more on the left side of things, but kind of let you explore some of those on the right side. I know other courses have you look into some of that a little bit, so I don't feel so bad kind of punting off some of that, but I might still randomly grab some of those things and put it onto an activity or, your final exam so that you can, make use of some of this crazy internal entropy testers and things like that as well. So anyway, a lot of backstory, I guess, but let's jump into our first one. And then the rest of the section of videos, I'll just basically do like one system, chat about some of the code, run a few comments on it, and then rinse and repeat. So this first one might be kind of long, but oh well, we're going for it. So I do want to kind of set the stage basically like as far back as we would like. So this, 1946 timeline with John von Neumann, and this square the middle or middle square approach, which is actually the one that I doodled on at the very beginning here, is that we're going to have some numbers and they're going to recreate things. It was also this first one that I had in this classic pseudo random number generator list. And it's also going to be the first one that we look at here. So some of you that have taken, Math 201 with me have seen this process before, just because I always think it's a cute one that students should see. It's also one that's kind of fun to implement and see where some of these cycles are going to lie. So the idea here is that you're going to take your favorite number, your favorite n-digit number. So here, if I live with 4 as being the number of digits, I can take LEET, so 1337, as my little seed value. I'm then going to square this thing. So the square of any of these 4-digit numbers could be up to being an 8-digit number. So you can kind of think about having an 8-digit number on the backside of the square. Here, squaring 1337 is actually going to be a 7-digit number, but I can view it as an 8-digit number if you just pad it with an initial 0. And then I'm going to extract out the middle 4 numbers. So basically, throw those away, and keep the 7875. That will then generate the next number in this sequence, and then you can keep this process going on and on and on and on and on. I should mention that in the discussion of some of this random number generation, sometimes we want to actually just generate like a random number on the backside, though that's typically going to be connected to generating some nice little random sequence. So most of the ways that I'm going to present them here, we're actually going to be generating random sequences, and you can think about running those as many times as you'd want to actually see your final output. They're a little bit more interesting to look at in terms of kind of what's happening long term, kind of where everything is dancing around and doing stuff. So we'll have this process, it'll generate the next term, it'll then generate the next term, it'll then generate the next term. So you'll end up getting this little sequence. From the sequence, you can then extract out a final answer if you would want. You can just, kick it off at a certain ending time, and that becomes the answer that you're going to give. But just a note is that we'll actually be generating sequences, not little singleton numbers. So the 7875, that's your next number in your sequence. And then to generate the next thing, you're going to square it, grab the middle numbers. So 7875, that actually does square to becoming an 8-digit number. So we throw away the 62, we throw away the 25, and we record the middle stuff. So the 0156. Notice that that's actually only a 3-digit number. So when I square that, we might start shrinking a little bit, but we'll see some interesting things happen in the long run to this sequence anyways. So that one's a pretty easy one to hand doodle. It's kind of annoying to square some stuff, but that's about as bad as it gets. So I'm going to switch over to some code just so we can kind of see some of the cycle things as why this process is really not a good process for generating random numbers, but it is, like I said, a fun starting place. So I have a whole bunch of these links open. So I hope I'm going to open up the correct one. I have all of the next ones that you're going to see. So you can kind of count up the number of videos that we have in our future. They're not going to be as long as this first one. So here you can see the printout actually occurring over on the right. And if I, go back and turn off some of these printout statements, it'll look maybe just a little bit better, or I can turn on some of the extra printout statements if I want some of those as well. But what's happening is I'm going to have my initial seed value, so that 1337. I'm going to start storing those into a list called scene. And basically, once I start seeing numbers again, I'm going to break out of this process so that I don't just get in this kind of infinite, loop of terrible things. Because my outputs are always only going to be 4-digit numbers, I know there's only, about 10,000 4-digit numbers. So I'm inevitably going to see some type of repetition emerge. Again, one of the issues with this system is that it's going to eventually cycle on itself, but it's kind of an issue with any of these systems is that they will tend to cycle. This one just cycles really, really fast. So the scene is going to be basically our way out of this process. The counter is going to keep track of how many things that I've actually seen, and then I'm going to just have a big old while loop that's going to do all of the heavy lifting. So while the current number that I'm working with has not been seen, so I've not padded my scene or not put anything into it yet, my counter goes up by 1. I add the number to the back of the bin, and then I do some really inefficient arithmetic just because I wanted to get my printout statements to look kind of nice. So I'm going to take my number and I'm going to square it. Then I'm going to store that thing as a string, and I'm going to pad on some zeros if need be so that it looks nice and tidy like that over there. Then I have my actual full-on printout statement. So that's creating this bin of stuff. So you have your number, it being squared, the output of that thing as this 8-digit number, and then I'm going to extract out the middle things. So here that's going to be those things that, I'm not including the first 2 things. So if I view that, I'm not going to grab the thing at index 0 or index 1. I'm going to go from 2, 3, 4, and 5. So I'm going to grab those things out of that, and then that becomes my next number. So your 1337 squared becomes this big thing. You grab the middle 4 things, so 7875. That becomes your next number to make it look nice and pretty. I also rep that thing out in binary. So 7875 is going to be that beast on the backside. And then you start that process over again. So 7875, square it. It's going to kick out 156. 156 squared, middle is going to be 243. 243 squared is going to generate 590. So officially that's 0590. Then you take that 590 squared, and it's going to have 3481. So it seemed like our numbers were getting kind of small, but then all of a sudden we do pop up to a slightly larger one again. So 3481, you square that, I'm back actually to an 8-digit number. The middle things on those are 1173 and so on and so forth. What you'll see here is that towards the end, we get stuck into a little loop. We are going to see the number 6,100 generated. When you square that, the middle of that is 2,100. When you square that, the middle of that is 4,100. When you square that, the middle of that is 8,100. And then finally, if you square 8,100, you are back to 6,100. What that means is that this little loop of 4 things is going to constantly repeat. I'm now stuck into that. There's no way for me to actually break out. So that's actually how we got kicked out of this while loop, is because 6,100 would have been stored in my list of seen numbers. So when I regenerate 6,100 again, I know to break out of this, and then it's actually going to print out how long that little cycle happens to be. Here, my cycle happens to be of length 4. If you change your input, so let's flip it around. So I have the reverse of LEET. If I were to run that, we will see some different things emerge. So if I look at that one, so I have my 71 or 7331. You can see it dances around and it generates some random looking stuff. But at the very end, it also gets stuck into one of these little cycles. It finds 9,600. And then it finds 1,600, then 5,600, then 3,600, then 9,600 again. So it creates a bunch of stuff early on, but if you let that process go too long, it's going to stabilize into this little bin of 4 things. If you were to generate some really unfortunate things to start, you can see some really bad stuff possibly emerge. So if you were to kick out all 1s, you'll see also that same kind of cycle emerge towards the end. It dances around early on, but then later does end up getting stuck into one of those things. So as I mentioned before, because we know that there's only going to be 10,000 possible outputs, we know that eventually you're going to hit something that you've seen before. It is inevitable. So by having that finite number of outputs, we're going to loop into it at some point in time. And then at that point in time, it starts over again. So for those of you that have been in my Math 201 course, you may have seen that process. There's a couple that actually have really short cycles. So there's some numbers that will just auto-generate themselves immediately. So I think it's like 3916 or something. I should have written it down before I started recording, but it's something like that, which will automatically regenerate itself in one step. Other ones have slightly longer cycles, but eventually they will start to stabilize as well. So cool. I'm going to pause it there just because that's kind of supposed to be the intro one, as well as just kind of some early examples of those things, which ended up being a little bit longer. But my other ones will be, here's a new system. Let's generate some things. Let's look at the code, come back, rinse, repeat over and over and over again. Most of the time when it comes to the actual printouts, we'll look at something like this, which will be not as much on the printout side so that it doesn't have to keep track of all of those little things, because you maybe just don't care about those. So you'll see that in some of our later ones where it doesn't have all of that extra stuff printed out, which is kind of where it starts, where it ends, and then what my final cycle length is going to be. Okay, cool. See you in a couple minutes, or I don't know, a couple seconds, however long it takes you to go to the next video.